last class we have discussed about halogens, the seventh A group of the periodic table, constituting 5 elements, namely fluorine, chlorine, bromine, iodine and astatine, are regarded as halogens. According to Greek, halogens means sea-borne salts, as they occurs in seawater abundantly. The electronic configuration of halogen indicates that all the elements are having 7 electrons in the valence shell in the form of Ns2Np5. Hence, the general electronic configuration of halogens can be represented as Ns2Np5. Except fluorine, all the elements shows variable oxidation states. That is from -1 to +1, +3, +5 and +7. Whereas the oxidation state of fluorine is only -1 always. All the halogens are monovalent as they have 1 electron less to complete their octave. Halogens have low value of melting point and boiling points and are highly electronegative in nature and are very reactive. They have low ionization energy value. The vapors of halogens are usually colored. Fluorine vapors are colorless. Chlorine vapors are pale green color. Bromine vapors are reddish brown in color, whereas iodine vapors are violet in color. All the halogens are diatomic in nature, like hydrogen H2, oxygen O2 and nitrogen N2. Coming to the chemical properties. Under chemical properties, we have to deal with action of halogens with hydrogen, combination reactions of halogen with metals and non-metals, action of halogen with water, action of halogens with halides, action of halogens with alkali, and the oxidizing properties of halogens. So coming to the first one, that is action with hydrogen. All halogens are being highly electronegative in nature. They are very reactive and they readily combine with hydrogen, forming respective hydra acids. For example, Cl2 combines with H2 to form 2 moles of hydrogen chloride. Likewise, 1 mole of bromine combines with 1 mole of hydrogen to form 2 moles of hydrogen bromide. Similarly, 1 mole of iodine, that is I2, combines with 1 mole of hydrogen H2 to form 2 moles of hydrogen iodide. The hydra acids formed dissolve in water, giving a strong solution of an acid. For example, when 1 mole of water is mixed with hydrogen chloride, a strong solution of hydrogen chloride is formed. When hydrogen bromide is mixed with water, a strong solution of hydrogen bromide is formed. Similarly, hydrogen iodide, a strong solution is formed when water is mixed with hydrogen iodide. Coming to the second reaction of halogens, that is combination reactions. All the halogen combines with most of the metals and non-metals to form respective salts. with metals. Halogens being highly electronegative element, they readily combine with highly electropositive metals. As halogens are highly electronegative, they readily combines with highly electropositive elements. Here it reacts with metals, that is all halogens reacts with metals like lithium, sodium, potassium, magnesium, calcium and aluminium, etc. Here halogens reacts with almost all with alkali metals, alkaline earth metals and D block elements, and it also reacts with aluminium to form respective chloride. For example, 1 mole of chlorine combines with 2 moles of sodium to form 2 moles of sodium chloride. Bromine reacts with sodium to form sodium bromide. Iodine combines with sodium to form sodium iodide. Halogens, especially chlorine, combines with magnesium to form magnesium chloride, and chlorine combines with calcium to form calcium chloride. Likewise, halogens, especially chlorine, combines with 2 moles of aluminium to form aluminium chloride. Action with non-metals. Halogens readily combines with hydrogen, a non-metal, forming respective hydrohalides. That is, F2, fluorine combines with hydrogen to form 2 moles of hydrogen fluoride. 1 mole of chlorine combines with 1 mole of hydrogen, forming 2 moles of hydrogen chloride. Likewise, bromine combines with hydrogen to form hydrogen bromide, and iodine combines with hydrogen to form hydrogen iodide. Coming to the action of halogens with water. Fluorine, chlorine and bromine readily decomposes water, giving oxygen and forming respective hydrohalides. That is, 2 moles of halide combines with 2 moles of water, forming 4 moles of hydrohalides with the liberation of oxygen. Here, water undergoes decomposition into oxygen. For example, 2 moles of fluorine combines with 2 moles of water, forming 4 moles of hydrogen fluoride with the liberation of oxygen. Similarly, 2 moles of chlorine combines with 2 moles of water, forming 4 moles of hydrogen chloride with the liberation of water. Here with the liberation of oxygen, here water undergoes decomposition. Similarly, 2 moles of bromine combines with 2 moles of water, forming 4 moles of hydrogen bromide and oxygen. Water undergoes decomposition again. Iodine, however, reacts with water in presence of a reducing agent. Action with alkalis. Except fluorine, all the halogen reacts with alkalis in cold and hot conditions, forming respective salts and also hypohalides and hypohalates. For example, action of halogens with cold and dilute alkalis. Except fluorine, all halides reacts with cold and dilute alkali like sodium hydroxide, forming sodium chloride, a salt, and sodium hypochlorite and water. For example, 2 moles of sodium hydroxide in cold and dilute condition reacts with chlorine to form 1 mole of sodium chloride and 1 mole of sodium hypochlorite, that is NaOCl, sodium hypochlorite. Under cold and dilute condition, sodium hydroxide forms hypochlorite, whereas in the hot condition sodium hydroxide form hypochlorate. That is, with hot and strong alkali solution. Except fluorine, all halides reacts with the hot and concentrated alkalis like sodium hydroxide, forming sodium chloride and sodium hypochlorate. As I have told earlier, alkali with halides under cold and dilute condition forms respective hypochlorides, and again the alkalis with halogen under strong and hot condition forms respective hypochlorates. For example, 6 moles of sodium hydroxide, a strong and hot solution of sodium hydroxide, reacts with 3 moles of chlorine, forming 5 moles of sodium chloride and 1 mole of sodium hypochlorate. Fluorine, however, gives oxygen difluoride with alkalis. For example, 2 moles of sodium hydroxide reacts with 2 moles of fluorine, forming 2 moles of sodium fluoride, and also there is a formation of oxygen difluoride and 1 mole of water. Oxygen difluoride is formed when fluorine is reacted with sodium hydroxide. Coming to the oxidizing properties of halogens. Except fluorine, all other halogens in their aqueous solution acts as an oxidizing agent. Hence, they oxidizes sodium nitrite to sodium nitrate and potassium sulfite to potassium sulfate. All halogen acts as a oxidizing agent in the aqueous condition. Hence, they oxidizes sodium nitrite to sodium nitrate and potassium sulfite to potassium sulfate. That is, NaNO2 is converted into NaNO3. 1 mole of sodium nitrite, NaNO2, in presence of halogens under aqueous condition, they oxidizes sodium nitrite NaNO2 to NaNO3, that is sodium nitrate. Here sodium nitrite gets oxidized to sodium nitrate, that is NaNO2 gets oxidized to NaNO3 in presence of halogens under aqueous condition. Similarly, as I have already told, potassium sulfite oxidizes to potassium sulfate. Potassium sulfite oxidizes to potassium sulfate, that is K2SO3, potassium sulfate, in presence of halogen, that is bromine, under aqueous condition. Potassium sulfite is oxidized to potassium sulfate with the formation of 2 moles of hydrogen bromide. Potassium sulfite K2SO3 in presence of halogen under aqueous condition forms or oxidizes to potassium sulfate and forming 2 moles of hydrogen bromide. Potassium sulfite gets oxidized to potassium sulfate in presence of halogen under aqueous condition. Formation of interhalogens. Halogens being most reactive, they react with each other forming the compounds called interhalogens. These compounds are of the type AX, AX-III, AX-5 and AX-7. Halogens being most reactive, they react each other forming a compounds called interhalogen compounds, and there are four types: AX type, AX-III type, AX-5 type and AX-7 type, where A and X are two different halogens, where A and X are two different halogens. Now coming to the interhalogen compounds. Each halogen atom has a combining capacity with another halogen atom to form several compounds among themselves, and the compound formed by the combination of two different halogen atoms are called as interhalogen compounds. Interhalogen compounds means one halogen atom is combined with another halogen atom, forming a compounds are called as interhalogen compounds. While naming the interhalogen compounds, the less electronegative atom or a larger halogen atom is written first. As we seen from the periodic table and their properties, particularly coming to the 7th A group, that is halogens, the electronegativity value will be goes on decreasing as we move from top to bottom in a group, that is from fluorine to chlorine, chlorine to bromine and bromine to iodine. As we move from fluorine to chlorine, the electronegativity of fluorine is higher than that of the chlorine, and from moving to bromine, the electronegativity value of bromine is lesser than that of the chlorine. Likewise, the element iodine is again a lesser electronegative in character. So, as we move from fluorine to iodine, the electronegativity value will be goes on decreasing, or in the other word, as we move from fluorine to iodine or astatine, the size of the elements will be goes on increasing. It means iodine is a larger halogen atom, whereas fluorine is the smallest halogen atom. While naming the interhalogens, we have to take a less electronegative atom or a larger halogen atom first while naming the interhalogen compounds. Types of interhalogens. Mainly there exists four types of interhalogen compounds, and they are of the type AX, AX-III, AX-5 and AX-7 type, where A and X are two different halogen atoms. Coming to the first type of interhalogens, that is AX type of interhalogen. In AX type of interhalogen, one of the each halogen atom is present. The well-known example of this type are chlorine monofluoride, bromine monofluoride, bromine monochloride, iodine monochloride, etc. These are all linear compounds. The thermal stability of the compounds decreases in the order from iodine monofluoride to bromine monofluoride, bromine monofluoride to chlorine monofluoride, chlorine monofluoride to iodine monobromide. Likewise, the bond length of the molecule also indicated as shown. BRF, that is bond length between bromine and fluorine in bromine monofluoride is 1.756 Armstrong unit. The bond length between chlorine and fluorine in chlorine monofluoride is 1.628 Armstrong unit. Likewise, the bond distance between iodine monochloride is 2.321 Armstrong unit. The interhalogens of this type are more reactive than the halogens. The interhalogen compounds of this type are more reactive than halogen atoms themselves. The reason is that the AX bond energy is less than AA bond type or XX bond type. That's why the interhalogen of this type are more reactive. Coming to the second type of interhalogens, that is AX3 type. In this type, 3 atoms of one halogen combines with 1 atom of other halogen. Examples are Examples of AX3 type are ClF3, that is chlorine trifluoride, BrF3, that is bromine trifluoride, and ICl3, that is iodine trichloride. The thermal stability of these compounds decreases in the order, that is from bromine trifluoride to chlorine trifluoride and chlorine trifluoride to iodine trifluoride. Now coming to the interhalogen of the type AX5. In this type, 5 atoms of one halogen combines with 1 atom of another halogen. The well-known examples of this type are iodine pentafluoride and bromine pentafluoride. Coming to the interhalogen of the type AX7. In AX type of interhalogens, 7 atom of one halogen combines with 1 atom of another halogen. IF7 is the only example of this type. Now coming to the preparation properties and structure of interhalogen compounds. So coming to the first one, that is interhalogen compound of the type AX. Here we have to see the preparation properties and structure of chlorine monofluoride as an example. Coming to the preparation. Chlorine monofluoride is prepared by the direct combination of fluorine and chlorine in a copper tube at 250 degrees centigrade. That is, it is obtained by the direct combination of chlorine and fluorine in a copper tube at 250 degrees centigrade. That is, Cl2 directly combines with fluorine to form 2 moles of chlorine monofluoride. That is, 1 mole of chlorine Cl2 combines with 1 mole of fluorine F2 to form 2 moles of chlorine monofluoride. Coming to the physical properties of chlorine monofluoride. Chlorine monofluoride is a colorless gas with a characteristic odor. It dissociates on heating into free chlorine and free fluorine as, that is, when 2 moles of chlorine monofluoride are subjected to heating, it undergoes dissociation to give free chlorine, that is Cl2, and free fluorine, that is F2. Coming to the chemical properties of chlorine monofluoride, that is action of sodium chloride on chlorine monofluoride. Chlorine monofluoride reacts with sodium chloride to form sodium chloride with the liberation of free chlorine, that is NaCl, sodium chloride reacting with ClF gives rise to NaF, sodium chloride, liberating free chlorine. Similarly, action with metals and non-metals. ClF reacts with a metal aluminium to form aluminium fluoride. That is, when we treat 2 moles of aluminium with 6 moles of chlorine monofluoride, 2 moles of aluminium trifluoride is formed with the liberation of 3 moles of free chlorine. Coming to the action of chlorine monofluoride with uranium. Chlorine monofluoride reacts with uranium forming uranium hexafluoride, liberating free chlorine, that is a metal uranium U combining with 6 moles of chlorine monofluoride, that is 6 ClF, gives rise to uranium hexafluoride, that is UF6, with the liberation of 3 moles of free chlorine. Coming to the action with sulfur. Chlorine monofluoride reacts with non-metal like sulfur, forming respective fluoride, liberating free chlorine. That is, sulfur reacting with 6 moles of chlorine monofluoride, it gives sulfur hexafluoride with the liberation of 3 chlorine. In all the chemical properties, when we treat chlorine monofluoride with metals or salt or with non-metals, in all the cases a free chlorine is liberated. Coming to the second compound, that is iodine monochloride ICl, which is of the type of AX type interhalogen compound. Regarding the preparation of iodine monochloride. Iodine monochloride is prepared by passing chlorine over solid iodine below 0 degree centigrade. That is I2 combining with the Cl2, it forms 2 moles of iodine monochloride. 1 mole of iodine combining with 1 mole of chlorine, it gives rise to 2 moles of iodine monochloride. Iodine monochloride exists in 2 different forms, that is stable form and metastable form. Stable form of iodine monochloride is a red needle-like crystalline compound and it melts at 27.3 degrees centigrade. Whereas the metastable form of iodine monochloride is a blue solid and melts at 14 degrees centigrade. Coming to the uses of iodine monochloride. A solution of iodine monochloride in glacial acetic acid is used for the estimation of iodine number, which is a measure of oil-signed fats. Coming to the last bit of the AX type interhalogen compound, that is structure of AX type interhalogen. Interhalogen of the type AX are all linear in structure. The central halogen atom involves sp3 hybridization. The following figure shows a linear structure of iodine monochloride, where iodine of one molecule of iodine monochloride is linked with another iodine atom of the another iodine monochloride molecule. Likewise, it forms a linear structure to the AX type of interhalogen compounds. The structure indicates the linear structure of ICl, or simply AX type of interhalogen compound, it involving sp3 hybridization. So this is regarding the interhalogen compound of the type AX, particularly iodine monofluoride and iodine monochloride, its preparation, its properties, their uses, and the structure of iodine monochloride. So today I am going to finish my class here only, and again from next Friday 10 to 11 I am going to discuss about the AX3 type, AX5 type and AX7 type of interhalogen compounds. Thank you.